Good morning, everyone. We are down to the second week of our fourth quarter in Mathematics 9. For this day, we're going to discuss the trigonometric ratio of special triangles. Okay, so before we discuss our topic for today, we need first to review this topic that we have discussed last meeting. Okay. So last meeting, we have discussed the sixth trigonometric ratio of the right triangle. Okay, we have here this right triangle here, and this side opposite the right angle is called the hypotenuse. So this side is always called the hypotenuse, or the longest side in the right triangle. Then, if this angle is the angle theta, or the reference angle, then this side, which is near to that angle, is called the adjacent side. While this side, which is remote or opposite that reference angle, is called the opposite side. Okay. But if this angle is the angle, for example, angle beta, okay, if this angle or this acute angle is angle beta, and this angle is the reference angle, then still this will be the hypotenuse, but this time this will be the adjacent side. And this side will be the opposite side if this angle is the reference angle. Okay, so we will use the term hypotenuse, opposite side, and adjacent side to solve for the sixth trigonometric ratio. Okay, this time in this figure, we will use this angle theta as the reference angle. Okay, so we have here the primary trigonometric ratio, the sine theta, cosine, and the tangent. Okay, so we have here the mnemonic so, ka, tawa. Okay, para mas madali nyong ma-memorize. So, S for sine theta is equal to opposite over hypotenuse. Okay, so in this figure, this is the opposite and this is the hypotenuse. So, sine theta is equal to opposite over hypotenuse. Okay, for cosine theta, we have the formula adjacent over hypotenuse. Okay, so to solve for the cosine theta here, we have adjacent divided by hypotenuse. Okay. For the tangent theta, or tan theta, we have the opposite over adjacent. So if this is the reference angle, we have opposite over adjacent. So those are the three primary trigonometric ratios. We also have here the secondary trigonometric ratio, wherein these are the reciprocal of the primary trigonometric ratio. For example, cosine or cosecant theta is the reciprocal of sine theta. If sine theta is equal to opposite over hypotenuse, its reciprocal is hypotenuse over opposite. Yung kabaliktaran niya. So, pagbabaliktarin lang yung numerator and denominator. Cosine theta has reciprocal secant theta. Okay, so yan naman yung dalawang mag-reciprocal. So, if cosine theta is equal to adjacent over hypotenuse, then its reciprocal will be hypotenuse over adjacent. Same goes with tangent and cotangent. They are also reciprocal of each others. So if the formula in finding tangent theta is opposite over adjacent, then its reciprocal, which is cotangent theta, will be adjacent over opposite. Let us discuss some examples in finding the 6 basic trigonometric ratio of this two figure. Okay, the first figure is triangle ABC or triangle ACB with side C as the hypotenuse, side A and side B are the legs. Okay, so since this is our reference angle theta, ayan, so if this is the reference angle theta and this side C is always the hypotenuse. So, lagi yan. Then, eto yung ating magiging adjacent side. Kasi yan yung malapit sa ating reference. Then, eto, na side na to, ang ating magiging opposite sides. Okay, so, adjacent, opposite, and hypotenuse. Okay, dito naman sa figure, nandito ang ating angle theta. So, again, ito pa rin ang ating hypotenuse. But this time, ito yung malapit sa angle. So, ito na ang ating magiging adjacent. So, yung adjacent side. Ito ang ating magiging opposite. Okay, that is opposite side. Palitan natin to. Tanggalin natin to para hindi kayo malito. Ayan. So, ayan. Okay, to solve for the sine theta, SOH, so sine is equal to opposite over hypotenuse. So this is the reference angle. Opposite is A divided by hypotenuse is C. So A divided by C. A over C. And the reciprocal of sine is cosine. The reciprocal of sine is cosecant. Ayan, the reciprocal of sine is cosecant. If this is AC, then its reciprocal is say, C over A. Okay, next, we have cosine theta is equal to adjacent over hypotenuse. So this is the angle. This is adjacent. This is hypotenuse. So B over C. Ayan. So, cosine theta is equal to B over C. And the reciprocal of cosine is secant. So, the reciprocal of BC is C over B. Next is for tangent. What is the tangent of this theta? Okay, tangent is equal to opposite over adjacent. So, this is the angle. Opposite is A, adjacent is B. So, A over B. Ayan. So, tangent theta is equal to A over B. Next, for this figure, we will also find the 6 basic trigonometric ratio. But this time, this is the reference angle. Okay, so sine theta of this angle is opposite over hypotenuse. So, opposite is B, hypotenuse is C. So, B over C. Ayan. B divided by C. And the reciprocal of sine is cosecant. The reciprocal of BC is C over B. Ayan. For the cosine of this angle, cosine is equal to adjacent over hypotenuse. So A over C. So A over C. And the reciprocal of cosine is secant. So the reciprocal of A over C is C over A. Same goes with tangent. So tangent theta is opposite over adjacent. So opposite is B, adjacent is A, so that is B over A. And the reciprocal of tangent is cotangent. So the reciprocal of B over A is AB. Therefore, cotangent theta is equal to A over B. Okay, let us now discuss our topic for today, which is finding the 6 basic trigonometric ratio of special right triangle. In our previous discussion, we have discussed the 2 special right triangle. The first one is the 45 degrees, 90 degrees right triangle, while the other one is the 30 degrees, 60 degrees, 90 degrees right triangle. Okay. So before we proceed in finding the 6 trigonometric ratio, let us first study this theorem on the 45, 45, 90 degrees right triangle. Okay, so you need to be familiar with this theorem in order to find the missing part of the special right triangle. Okay, so gagamitin nyo siya if there are missing parts or missing sides or missing leg or maybe missing hypotenuse of the 45, 45, 90 degrees right triangle. And these are the theorems. Number 1, the legs are congruent. So the length of this leg and the length of this leg is always the same. Say if this is 2 centimeters, this is also 2 centimeters. Next, the length of the hypotenuse is the square root of 2 times the length of the leg. So kung ano yung nandyan na measure, lalagyan lang natin siya sa katabi ng times the square root of 2. Say, if the leg is 2, the hypotenuse is 2 the square root of 2. If the leg is 5, the hypotenuse is 5 the square root of 2. So, ayan. So, you should know and be familiar of that theorem. Next natin is the 30 degrees, 60 degrees, 90 degrees right triangle. So this is the figure. This side opposite the 90 degrees angle is always called the hypotenuse. So laging hypotenuse yan. Okay. So that side opposite the 30 degrees, ayan, opposite siya. Ang tawag naman dyan ay shorter leg. Okay, shorter leg. While this side opposite the 60 degrees angle is called the longer leg. Okay, so yung pinakamaikli dyan na side, yan yung shorter leg. Yung pinakamahabang side, that is the hypotenuse. And the remaining side is the longer leg. Okay, so these are the theorems that you need to be familiar with. Okay, so gagamitin natin ito again kapag merong mga missing sides ng 30, 60, 90 degrees right triangle. Number 1, the length of the hypotenuse is twice the length of the shorter leg. Okay. So for let's say the hypotenuse is 10 centimeters. The shorter leg is 5, kalahati. So if this is 20, this is 10. If this is 50, this is 100. Okay, ganun lang siya. Next, the length of the longer leg is the square root of 3 times the length of the longer leg. Let's give an example. For example, the hypotenuse is 20. Okay, the hypotenuse is 20 centimeters. The shorter leg is 10 centimeters. Kalahati ng hypotenuse, so 10. So, eto, na longer leg, that is 10, the square root of 3. Shorter leg times the square root of 3. So, that is 10, the square root of 3. Okay, so, ayan. Yan yung mga dapat yung tandaan sa ating 30, 60, 90 degrees right triangle. Okay. Let us now solve for the trigonometric ratio of the special right triangle. Okay, so sa figure natin, lahat naman ay meron ng mga measurements. Yung hypotenuse natin is 2, shorter leg is 1, and the longer leg is the square root of 3. So, no need to use the theorems kasi nandyan na siya. Pero, iti-check ulit natin to kung tama ba yung theorem kanina. Let's check. If the hypotenuse is 2, kalahati ng 2 ang magiging length ng shorter leg. So, kung 2 yan, ang kalahati niyan ay 1. So, that is correct. So, dito naman sa longer side, kukunin lang yung number dito. So, we have 1, tapos lagyan ng the square root of 3. So, that is 1, the square root of 3, or simply the square root of 3. Okay, tama naman siya using our theorems. Okay. So, let's say, ang hahanapin natin is tangent 30 degrees. Let us look for the value of tangent 30 degrees in this figure. Okay, so we all know that tangent theta is equal to opposite over adjacent. Since yung hinahanap natin ay 30 degrees, ang magiging reference natin ay etong angle na to. So, this angle. Ayan. So, 30 degrees. Kaya ito yung kukunin natin. So, ang hinahanap natin ay tangent, which is opposite and adjacent. So, ito yung ating hypotenuse. Ito yung ating adjacent. So, ito ang ating opposite. Ayan. So, substitute na natin sa ating yung value sa ating formula. Tangent 30 degrees is equal to opposite over adjacent. Ang opposite natin ay 1. So, we have 1 divided by the square root of 3. So, 1 divided by the square root of 3. Since meron tayong radical sign sa ating denominator, kailangan natin siyang tanggalin by multiplying a number na mawawala yung ating radical sign. So, kailangan natin siyang i-multiply ng the square root of 3 para maging perfect square numbers yung ating denominator. So, kung magmumultiply tayo sa numerator ng the square root of 3, sa denominator, kailangan din natin magmultiply sa numerator ng the square root of 3 also. Ayan. So, kaya siya magiging 1 times the square root of 3 is, of course, the square root of 3. Then, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 is equal to 3. Kaya, tangent 30 degrees is equal to the square root of 3 over 3. So, that is for tangent. Okay, let's solve for another example. Okay, wag na natin tanggalin to kasi yan naman talaga ang ating hypotenuse. So, this time, try natin hanapin ang sine 60 degrees. Okay, what is the value of sine 60 degrees? Okay. Since 60 degrees yung nandito, ito ang ating magiging reference angle. 60 kasi yung nandun. So, kung ito yung reference angle, ito ang ating magiging adjacent. Kasi yan yung malapit. Then, ito ang ating magiging opposite. Okay, so balikan natin yung formula natin for sine. Sine theta natin is so, di ba? Naalala nyo? So, yung formula natin. Sine is equal to opposite over hypotenuse. So, to solve for sine 60 degrees, okay, that is equal to, opposite nyan ay the square root of 3. And the adjacent is simply 1. So, the square root of 3 over 1 is simply the square root of 3. So, therefore, sine 60 degrees is simply equal to, ayan, 3, the square root of 3. So, ganun lang siya. Same goes kapag magsasolve tayo ng other trigonometric ratio. Okay. Discuss naman natin ngayon yung ating trigonometric ratio of a 45, 45, 90 degrees right triangle. Okay, katulad ng example kanina, meron na rin siyang mga sides or length of sides. Like, yung hypotenuse, the square root of 2, yung leg ay same, 1. Diba? Pareho siya 1. So, no need na to use the theorem. We will now proceed to finding the sine 45 degrees. Okay. So, kung napapansin nyo, pareho sila 45. So, kahit alin naman dyan ang kunin nyo, same din naman. So, halimbawa, eto. So, therefore, since pareho naman to, kahit eto yung gawin nating adjacent, okay lang. So, kahit eto yung gawin nating opposite, it's just the same. So, eto yung adjacent or pwede siyang maging opposite. Kasi same din naman yung value. So, this time, eto ang magiging hypotenuse. Lagi siyang hypotenuse. Kasi yan yung opposite ng ating 90 degrees angle. Okay. So, to solve for sine 45 degrees, ayan, to solve for sine 45 degrees, opposite over hypotenuse. So, opposite is 1. So, opposite is 1. The hypotenuse is the square root of 2. So, 1 over the square root of 2. So, katulad ng ginawa natin kanina, we need to rationalize the denominator dahil meron siyang radical symbol. So, the square root of 2, kailangan natin siyang i-multiply ng the square root of 2 para maging siyang perfect square. So, mag-multiply din tayo, of course, sa numerator. Ayan. So, 1 times the square root of 2 is 1 the square root of 2 or simply the square root of 2. And then, the square root of 2 divided by this, or the square root of 2 times the square root of 2, that is the square root of 4, and the square root of 4 is 2. Ayan. So, sine 45 degrees is the square root of 2 over 2. Okay, let us try to solve for another problem. Let's say, ang hanapin natin is tangent 45 degrees. Ayan, tangent 45 degrees. Okay, ano nga ulit yung formula natin sa paghanap ng tangent? We have TOA. Okay, TOA. Ayan. So, opposite over adjacent. So, ang opposite natin, ayan, opposite which is 1. Ang adjacent natin is also 1. So, that is equal to 1. Therefore, tangent 45 degrees is simply equal to 1.